Hey, welcome everyone that's here. Thank you for coming. I guess one thing I'll say before we even get started is we will be recording this session, so just to let you know of that. But yeah, thanks for coming. This is going to be a virtual workshop here. We're going to be talking serverless and how Amazon DynamoDB fits into serverless. It's going to be part lecture, part workshop here. So Pete Naylor, he's going to start off with the lecture part. He's a senior technical product manager at Amazon DynamoDB, and truly one of the people that's taught me the most about Dynamo. Some of the most interesting things, or the most nuanced takes. When I'm like, why doesn't Dynamo do this? He's the one explaining it to me. So Pete's really been a great mentor to me and teacher, and I love his insight on that stuff. So Pete, thanks for being here and being willing to share your knowledge with us.
Thank you, Alex, and thanks everybody for joining. I think it's Saturday morning in India and Friday evening for us here in the US. We're really excited about this workshop, and I'm super pleased that you're able to join us. I'm going to move really quickly through these first few slides. I want to kind of get a baseline of understanding and then hand it off to Alex because he's going to do a lot of the much more fun kind of hands-on stuff. So hang on to your hats. We're going to move quickly. All right. The brief slideshow part of this session is going to cover some of the properties. Why do we want a database? Why do we have a database as a part of our overall serverless application architecture? We're going to talk about DynamoDB data structure, how we index data, and how we scale. We'll talk briefly about kind of the mindset, because for most people, I think we bring a lot of experience with traditional relational databases, and DynamoDB really asks people to step outside of that and think a little bit differently, and try to take some of the access patterns that you might have used on a relational database in the past and solve for those problems with a different approach. We're going to talk about why DynamoDB is such a good fit in serverless architectures. And then I'm going to hand it off to Alex for the fun part of this. So let's get started. So I want to talk about why do we have a database, right? And why do we have a transactional database? And very often you'll hear people talk about ACID, ACID, and these are atomicity, consistency, isolation, and durability. These are the properties that you really want as a developer that makes it easy to develop around a transactional database. You want to know that when you make a change to your data, it's either fully committed or it doesn't get committed at all. You don't want to have some kind of a weird partial state in your data. You also want to have consistency. So if you make a change to your data and then you read it back again, you want to see the data that includes the change that you just made. And you want to place conditions on your change requests. You want to know that, say, I only want to commit this new piece of information if there wasn't a piece of information like that already, for example. And you want to have the database enforce that for you, because trying to do that in the application itself is very, very difficult and it's time consuming. You want to have isolation. So if you have multiple application threads working on the same data, you want to be sure that there are no conflicts, one change at a time, and a predictable end state. And durability, right? You want to make sure that if you've written this data, it stays there. It's not going to disappear one Saturday morning, right? That would be a bad weekend. Store it durably. You don't want to lose any of those changes in the event of a power loss or any of these kinds of things, a hardware component failure. So DynamoDB actually supports all of those things. I think that for many people, they hear about NoSQL and they hear things like, well, NoSQL is not consistent, or it can't do this and it can't do that. The truth is that DynamoDB does actually satisfy all of those things, and it makes it a really good fit for a lot of different applications. Let's talk about the data structure and the indexing in DynamoDB. First of all, we have a DynamoDB table. You don't have to think about a cluster or any of these kinds of things. It's just a collection of data. You can think about it a little bit like an S3 bucket. Here is our box that says we're going to store our data here in this table. In that table, we're going to store items, as many items as you need to store, and they're a little bit like a row in a relational database that you may be familiar with. Each of those items or rows has a set of attributes, which are a set of different values, almost like columns. And then we're going to have a particular one of those columns or an attribute that we name. We're going to say this is our partition key. And that's really a super important part of scaling with DynamoDB. You can also name optionally a sort key, which allows you to sort different items into a collection under a particular partition. Together, they become the primary key, which uniquely identifies every item, every row in your table. So the partition key is really what we use to, if we have a table that just has a partition key, we can model one-to-one relationships. This is really what we're talking about when we say key value. We can insert an item with a particular primary key. Anytime we want, we can go get that item again by saying, here's our key, give me the data that's associated with it. The partition key is also used by DynamoDB to automatically horizontally distribute that traffic across many different shards, as many as you need to scale to meet your needs. It can also be the identity for a collection of items when you have a sort key. So a sort key allows us the ability to model one-to-many relationships where we say, here's our partition key value. We're going to have a bunch of items that have the same partition key value, but different sort key values. And it collects them together. It allows us to make queries across that data that are very efficient. It allows us to filter across them and do sorting forward or reverse across those. More on this in a little bit. So within that sort key, we can actually retrieve subsets of our collection. We can say we want all of the items in the collection. We want all of the items where the sort key is equal to a particular value, less than, greater than, effectively a range type of a query. Begins with or between. We can get them, we can just retrieve the count, the number of items that are retrieved matching a particular condition, or we can get a certain number, right? We can say, give us the first 5 or the last 3 within that sorted collection. So it's a very powerful construct, I think, that is not just limited to here's a key, give me a value. When we can extend into a sort key and have item collections, we can do so much more. Let's talk a little bit about how DynamoDB scales. It scales horizontally and very much automatically. You really don't have to think about this. Let's imagine we have a use case where there's a table which is storing a bunch of information about your customers' orders. Maybe it's a retail application. We love to talk about orders here at Amazon, right? And we might automatically just or decide to set a primary key based on the order ID, right? That might be our unique identifier for each particular order. So our order IDs here are 1, 2, and 3. And in the DynamoDB table itself, we're going to hash those values. We're going to take order ID 1, we're going to hash it, we're going to find out that value is 7B, and it's going to fit in one of these partitions in the table across the hash space. We're going to do that for all of the items, actually. We're going to do the hashing for you, and that means that we can deterministically know which one of the partitions to go look in to get your data when you want to retrieve it. Because this hashing is for the most part random or close to random, even very small changes in the value of that primary key are going to evaluate differently, right? These records are going to be stored scattered very well across that hash space. So we can actually scale out the number of these partitions for you dynamically. We can add them as you need more throughput or more storage. And we're going to automatically manage the hashing and the partitioning for you. So there's this concept called normalization, and in the early days of relational databases, it represented this approach to modeling your data that would reduce data duplication. And way back in the day, when these databases were first being developed, the cost of durable storage was super high, and reducing the overall data volume was a high priority as a result, right? So if we look at the example data that we have shown here, you can imagine it might be, again, a retail sales application. We're going to have a table which stores the orders, another that stores information about the customers, and a third that stores merchandise details. So if we look at the orders table, we can see that customer 100 made 2 orders, but we don't record customer 100's details twice. We can reference that information from the customer 100 record in the customers table. The same is true for product 300. It was part of 2 different orders, but we only record the product details once. It's referenced by the product 300 in the products table. So you can see how this reduces the data duplication, but it comes at the cost of something called a join. A SQL database with normalized data structure depends on compute, on the CPU, to go and get the various entities from the tables and to kind of construct or build this complete result for the application. And what that means is if the CPU is busy or if other things are happening, the performance is a little bit variable. In DynamoDB, we tend to denormalize because there is schema flexibility, and that means that each of our items can have a different set of attributes. We don't have a fixed set of columns that we have to actually have values for. And there's no engine in compute to go construct the result through joins when we request it. We tend to store the result exactly as we want to read it later. And this is an important part of DynamoDB's scalability and the consistent performance that you get at any scale. Am I getting this correct, Alex? All right, I hope so. Okay.
Sorry, I was muted. Yes, definitely getting it correct so far there, Pete.
All right, good. Since you were muted, it really didn't matter if you disagreed. We were just going to move on anyway.
I'd been yelling at the
Okay,
screen. What is he doing? No, this is great.
okay, so now I want to really dig into a little bit more about item collections, right? It's this powerful functionality in DynamoDB. Remember we mentioned that a table with a composite primary key, so a primary key that has both a partition key attribute and a sort key attribute, allows us to collect items. So we say that all of those items are related because they have the same value of partition key. That set of items with unique primary keys, but the same value of partition key, is an item collection. And it allows us to narrow our queries by saying, look in the item collection that's identified by this particular value of partition key, and fetch me a filtered and optionally sorted set of items based on the parameters that I provide. So it's very easy to imagine a model that would use something like an IoT device ID as the partition key and the timestamp of a periodic sensor reading as the sort key. The reading itself is recorded as an additional attribute. So now we can do time-sorted range queries for a given device, which is really what we would love to do for this kind of an application. The sort ordering is not always important, and what's most important is that an item collection allows you to logically group that set of items. They're related by that partition key value. So let's recall that DynamoDB has that schema flexibility, and it means that items with different sets of attributes, different schema, can coexist in the same table. These are different entity types. They might be like sub-entities within an item collection. In fact, they can also be related by an item collection. And that item collection can be in the base table, that primary index, or we build it in a secondary index. So I want to suggest, I think that when you query a DynamoDB item collection containing multiple types of entities, it's a lot like a join, right? Alex, would you agree? It's kind of like you're using this to kind of instantiate this and record it. It's already on SSD. We're just going to go back and say, hey, give me piecemeal parts of this item collection, but it's already stored. It's very reliably consistent in terms of performance for that reason.
Yeah, totally agree. You were the one that taught me about item collections in the first place, and so flexible. Whether it's a bunch of orders or IoT readings like you're talking about, filtering down on those time ranges, or gathering collections of related but distinct types of entities, and doing that pre-joining that data and making that an efficient operation rather than one that has to jump all over the disk and burn through CPU
Yeah.
to make that happen.
I think this is the hardest part about like the mental shift about data modeling for DynamoDB is thinking this way and thinking, how can I build an item collection that will just like pre-build my
Yeah.
answer for me when I want to go get it, right?
Yeah.
Um, so one way I really like to get people to think about this is to think about DynamoDB as having actually two different types of record, right? We talked about items, which is a lot like a row, and then the other kind of a record in DynamoDB is an item collection. Um, and item collections allow you to efficiently change small parts of the overall record or to efficiently retrieve selective parts of the record, right? And so you want to think about how can I build item collections that serve my access patterns. So I want to talk a little bit about those transactional properties. In DynamoDB, it's a little bit different, and we typically use a multi-version concurrency control pattern to have locking. It's optimistic locking, effectively. Um, and the way we're going to do that is, an example here is, again, a shopping cart retail application. Um, the pattern we're going to use with DynamoDB is we're going to go get that cart record, and we're going to look at it, maybe an attribute that we've stored, which is the version number. Then in the application, we're going to make a change. We're going to maybe add or remove some items. Then we're going to go back and we're going to try to write an updated view of the item, but we're going to condition that. We're going to say that we want the version number to still be the number that we thought it was when we first read it, right? And if it's changed, we're going to go back and take a fresh look at that item and start over, essentially. This is really, the recommended way to go things when you're operating at scale and you have many different clients operating, because when you have pessimistic locking, things start to get a little bit left behind and slow. So this is the way that works in DynamoDB, and it does provide complete isolation and control. I want to talk a little bit about modeling steps, how we approach things with DynamoDB, and we'll see if Alex agrees with me here. I hope so. I'm going to cross my fingers. Um, I would say one of the first things to do is think about your data and the information that you want to store and map that out, believe it or not, in an entity relationship diagram. Same kind of thing that you might have done with a relational database, because you want to understand what you're storing and how the information relates to other pieces of information. This is where you're going to see, well, is it one to one? Is it one to many? How do these pieces of information relate? And how do I need to uniquely identify certain pieces of information? Then you're going to actually make a list of your access patterns. And one thing that I see a lot is developers who will say, well, this is a new application. I don't really know what my application, my access patterns are going to be. And I think that's just, while there's some truth to that, I often sit down, when I'm doing design reviews for DynamoDB, maybe with internal Amazon teams, I say, I think you probably have a list of APIs that you're going to expose to your customer, right? Let's sit down and look at those, because each one of those is going to have a particular data operation or a set of data operations that it's going to perform. And the truth is, if you actually sit down and make that list, you kind of know what the access patterns are. So get those in order and make your list. Um, when you look at those access patterns, you're going to see that the majority of them are going to say, well, there's this known value for a particular primary key. Go do this. Go check on this item based on this primary key. You're going to very quickly see that there are certain types of entities that you're going to model into one-to-one, one-to-many kinds of patterns. And how you're going to think about things like consistency and uniqueness, the kinds of things that you want to make sure, like you don't want to allow for multiple users in your game to have the same user ID, for example. That's a constraint you want DynamoDB to manage for you with uniqueness. So once you've got all of that stuff done, your main patterns, the things that you need to do, you might think about these as create, read, update, delete, your standard CRUD types of patterns. Then you're going to find that there's going to be these other secondary patterns, things that you want to be able to meet over and above that. And these are the things that you can model in DynamoDB with secondary indexes. Finally, once you've gotten to that point and you've started to build and create your proof of concept and learn about how it performs, do a critical review. Go back and validate the value of those indexes. Did you really need the index after all? Maybe you were wrong about some of those access patterns. You're going to iterate and retest. So those are the patterns that I would recommend. We have a tool you can download called Nosql Workbench that really helps through this process of thinking about your access patterns, iterating on the design, deciding how you want to store things. Do you want to have a table for some data? Do you want to actually group the data together into item collections in a single table? How am I going to create these indexes, and how am I going to query them? We find that a lot of folks like to use this for screenshots for their documentation. You can also export the model that you create and use that as part of your documentation for the team, because maybe in a couple of years when you come back and someone wants to add some new functionality to the application, it's like, what were we thinking? This tool can really help. You can import that and pick up things pretty quickly. So I know here's something Alex might have some more feedback on, but there's a lot of discussion out there about how many tables do we need. There's single table design, and I want to talk a little bit about what that really means. I think for single table design, for me, it really means taking advantage of item collections and understanding that there is schema flexibility. So you can have multiple entity types in the same table, in the same secondary index. Sometimes, if you have a complex enough application, you're going to find that some of your access patterns are completely unrelated. And maybe you want a different kind of primary key, a different data type for the partition key, these kinds of things. There are valid reasons to have multiple tables. When we talk about single table design, to me, that really means thinking about things from the perspective of building these item collections first. Oftentimes, you'll have some kind of operational need where you decide that actually certain subsets of data are better off in different tables, and they're for the most part not going to be read within a single request, right? You're going to make different requests, and maybe it really doesn't matter. So the things that bring us to DynamoDB really about reliably doing what we need to do at any scale. We want to meet our operational needs with minimal overhead, right? We definitely want that whole serverless experience. And the number of tables required to match those priorities is often greater one, and that's okay. So you can see here that we have Plato and Aristotle kind of having a discussion about how many tables. Someone says 1 and the other one says 5. I don't get too hung up on that, to be honest. Just think about those access patterns and work back from there and build something that works and scales well for your application. All right, so why go serverless with DynamoDB? Well, firstly, there's no servers to manage, right? No maintenance planning. I had a very operational background in my career, and I started supporting Amazon.com as a customer of AWS. I helped them with a lot of database migrations, and I saw what happened when they left this traditional database in a box in a rack thing behind. When they're trying to scale for something like Prime Day, they used to, like, massive teams of people would spend so much time trying to plan for these things, and there was so much overhead for them, and it was really a terrible thing for customers, because these people were so caught up in looking after operations that they weren't able to focus on the development itself. So I got to see what changed when they started to use serverless databases and be able to move so much faster and be more flexible and really spend their time developing features that mattered. So when we're using DynamoDB, we're reducing risk. We're not having to think about capacity. Do I have to, think about what my capacity needs will be a year from now because I have to order hardware, and then I have a bunch of stuff sitting in a rack. It's really the promise of cloud. You're going to protect your data with managed backups and restores, point-in-time recovery, and global tables. I really don't have to go through this in great detail because I want to move forward and get to Alex's part. But when you're talking about serverless, you're reducing risk, you're reducing cost, and you're able to move faster. And that's the key thing, I think, right? If you want to be a business that is able to compete in the business environment that we have today, you have to be able to move quickly with your development teams. So common patterns I think that we see is that we would have data operations here on the left. Maybe it's coming from Lambda. It's some kind of compute in a serverless environment. It's more than likely going to be Lambda, and it's going to be making data operations against DynamoDB. Very common pattern is to use DynamoDB streams, which is like change data capture. It stores events for every change that's made in your DynamoDB table. Based on those events, you can do kind of an event driven pattern here where Lambda is going to be triggered, a function that you create off of every change in that stream. That Lambda function might go back and actually aggregate it, might calculate something. It may go back to DynamoDB and record a different record or update a record in your table. Or it could capture that and send it off to Elasticsearch or OpenSearch to be able to do fuzzy text search across your data. Another pattern that's pretty common is to capture change, feed it through Firehose to kind of build bigger batches and create objects that are of a reasonable size for S3. Store it in S3 as a Parquet file or an object, and then you can query that with Athena, another serverless component. You can also notify changes. So, right, if you see something, some event that happened in your DynamoDB stream, you could send a notification through SNS to your ops team, perhaps. So there's a lot of things, a lot of very common patterns you can see in serverless architectures. I'm sure Alex has seen all of these things many times, but these are all very common. That's all I've got. I'm going to hand it off to Alex. I want to let you know that we have, there's a link here for Nosql Workbench for DynamoDB. It's a free download. Go grab it and take a look at it and maybe play around with some different design ideas that you might have. There is another workshop that you could go check out and plenty of other free labs. If you have any feedback for us, if you have any feature asks or things that you'd like to discuss, please reach out to us on Twitter. We're keeping an eye on that. And I think Alex is around there on Twitter also. We love your questions, and it's fun to think about different design ideas. That's all I've got. I'm going to hand it off to you, Alex.
Awesome. Thank you, Pete. Great job. And yeah, really good setup for some of the things we're going to talk about in the workshop, why it works so well with serverless. And especially I think those two patterns that you talked about, both your data operations and that change data capture processing with DynamoDB streams. So yeah, we're going to move over to the event or the workshop part of the presentation. A couple notes I want to say, because we've had some people that came in just after we got started. We are recording this, so just as an FYI in terms of that. Also, we're going to be doing the workshop session. I'm going to drop some links into the chat if you want to do the workshop yourself. So I just dropped in some setup instructions. If you want to use the provided AWS account, we're going to give you accounts that you can sign up for. It's going to be good for 12 hours. So that first link I set up describes how to do that. The second link actually gives you the code to set up that account for you. Additionally, I want to paste in two more links. And Amit, can you change it so that I'm the presenter? Okay. Thank you. So I'm sharing my screen now. I hope you all can see that. Hold on, let me get my windows all set up. Okay, so I did post a few more things into the chat, both the workshop instructions and the workshop code. So the workshop instructions I have, these are this right here. So this is a PDF of everything we're going to walk through today. You can do this. You can be doing this right now if you want to. You can also do it after the fact and that. The one thing I would say is that it's probably going to be a little too fast for you to try and do the things as I'm actually going through them. So I would advise either sitting back and listening and watching and trying to learn that way, or just saying, hey, I'm going to go through the PDF myself and do it. But if you want to watch right now, you can do it yourself later and do things like that. So this PDF has all that stuff for you. Also, we have the code repository. It's this Lambda DynamoDB workshop code that we have there. I saw someone say having some issues with the Git link there. I'm not sure on that one, but I'll try and move forward. It should be a public repo. If anyone can't access this repo, please let me know. But yeah, it should be a public repository, so it might be some Git config there type stuff. So anyway, that's some basic setup. I wanna move into the actual workshop stuff here. And just to give you a sense of what we're going to be covering here, we're going to be looking at, serverless applications and particularly why Dynamo works so well in these serverless applications. So we're not going to get into any DynamoDB data modeling stuff, which is a huge topic. Pete touched on some of that stuff and things you're thinking about there. AWS has a lot of other resources on that, so go check that out. Too big to cover in this as well, but we're really focused on serverless applications, this new sort of architecture pattern, and why Dynamo fits so well. This is how I got started with Dynamo, using serverless applications because it fits so well. So two main things I want to cover in this. The first thing we're going to cover is just the two ways you can use Dynamo in serverless applications. And Pete touched on this. You could use it for data operations, your primary database where you're reading from Dynamo, you're writing to Dynamo within your Lambda function. So that's going to be the primary way, as using Dynamo as your primary database. The second way to use Dynamo in serverless applications is using that change data capture, processing data changes using DynamoDB streams. So we'll take a look at that as well. In addition to looking at how we're using Dynamo in serverless applications, I just wanted to learn how to deploy and manage a serverless application generally. So we'll learn we'll learn about the services involved. We'll learn about AWS Lambda, API Gateway, things like that. But also we'll learn how to use infrastructure as code to manage and deploy your application, as that's a pretty important part of the service experience. So I'll be walking through with code throughout. I'll try and be interactive. I'm going to try and pay attention to questions, but I'll probably mostly just look at the chat, when something's deploying or something like that, just to keep us moving. But feel free to drop questions, and I'll try and mix those in as well. So first thing we want to do in the first module, if you're following along in the PDF, we just want to deploy a basic serverless application. We're not going to do anything with DynamoDB to get started. We're just going to say, hey, what is Lambda? How does that work? And how do I actually get something deployed? So three services or tools we're going to be using here. Number one is AWS Lambda. This is a serverless compute offering, function-based compute where you're basically uploading a zip file, and the Lambda service is going to manage running that function for you, running that code in response to events. So Lambda is this event-driven compute, which means you need events to sort of trigger your function and operate on those events. And one of the events you might use would be, HTTP request. So if an HTTP request comes in, you want to handle that with a Lambda function. To sort of bridge between your HTTP request and Lambda, you use API Gateway. So we'll also be setting up API Gateway here, and that's just, again, going to translate your HTTP request into something that the Lambda service can use and then send a response back to the client there. Finally, since we're going to be provisioning all this stuff, provisioning Lambda functions, provisioning an API Gateway, later provisioning DynamoDB, we want to use what's called infrastructure as code to manage all this different infrastructure, right? Because we're going to have a lot of resources scattered about. So rather than going into the console and sort of clicking to create this stuff, we're going to use infrastructure as code to manage that, and we'll use AWS SAM. So we'll look at that in this first workshop, first module of the workshop here. I want to start off by just writing our first Lambda function and getting a feel for what that looks like. So if you go into the source directory of the GitHub repo, there's a file called main.js. We can open this up. This is actually going to contain the code for our first Lambda function here. Two things I want to call out here. Number one, if you look at this top line, I'm exporting a function called handler. I can give it whatever name I want, but I usually call it handler. I'm exporting a function. This is going to be my actual Lambda function that's going to be invoked by these events, right? So I'm creating the zip file that's going to get invoked by events. This is the actual function that's going to get invoked. And when it's going to get invoked by events, it's going to pass in two arguments, event and context. So event is going to be the actual details of the event that triggered my function on this particular instance, right? So if that's an HTTP request, it'll include information like, the payload body, the path it was called on, the method, headers, anything like that, context about that event or information about that event. Whereas, if it's an SQSQ message, it'll have the details of that queue message. If it's a DynamoDB stream event, it's going to have the contents of that stream event. In addition to that, we have this context argument, which is just going to include sort of like meta information about the function environment, function name, some configuration options, stuff like that. So that's what you're going to have your function handler with those two arguments. You're also going to have a return. After your function code runs, you want to return something. And in this case, where we're going to be hooking up to API gateway and handling HTTP requests, we want to return a response as well, right? Because the other side of that HTTP request is a response. So we need to return things back like a status code, headers, a payload body, things like that. So if you're doing an API gateway connection in your Lambda function, you're going to have to return an object that includes the status code, that includes your body, that optionally includes headers, things like that. So that's what we're including here in our Lambda function. All right, so that's our Lambda function. Let's go into our infrastructure as code part. I'm going to check out a different part of this GitHub repository. So we have our Lambda function code, but again, remember we need, we're going to use infrastructure as code to manage all these different infrastructure. So we need to go create that Lambda function. We're going to be using AWS SAM for that, which is some tooling on top of AWS CloudFormation to make that easier. So if you open up this file called template.yaml, this is our AWS SAM template. I want to walk through what's going on here. These first few lines, this is just some metadata type stuff, format version, a description. It also includes this transform property, which says, hey, we're using the AWS serverless application model, AWS SAM, to transform our CloudFormation. It just makes some nicer things on top of CloudFormation, really geared towards serverless applications. Then once we start working with our CloudFormation, we have this resources block, and this is saying what resources we actually want to provision in our CloudFormation, right? So under that, I have a resource called main function. This is going to be the Lambda function that I provision. And within that, you have to specify the type of resource you're provisioning. So in this case, I'm provisioning a serverless function. This is going to be my Lambda function. So that code we just wrote, it's going to handle getting that up there and creating that resource. Additionally, you have to specify some properties that are going to depend on the type of resource you're creating. So here, we need to specify where my code lives and what the entry point handler is for it, right? So we have code URI, which is saying, hey, it's this directory that has my code in it. And then handler that says it's this specific file. Within the source directory, within that main file, I have a handler function that I want to be the entry point to my Lambda function. And that's what's going to get invoked with my event. You can also see we have a runtime here, just specifying the runtime we're running. And then we're also need to trigger up an event to our Lambda function because the function by itself doesn't do a whole lot. So you need to make sure you trigger events to it, whether that's SQS, API gateway, DynamoDB streams, you'll see that. In this case, we're using API gateway, so you can see the event we're hooking up is of type API. And again, we need to pass in some properties like the path, right? We're doing this on the root path of our API, and we're using the get method, the get HTTP method for this particular one. So what these 10 lines of code are doing right here is provisioning a Lambda function and also provisioning that API gateway and doing the connection between those two to make that happen for us. And it's going to do it in a nice repeatable way using infrastructure as code. Last thing you might have in your CloudFormation or your SAM template here is this outputs thing. If you have some values that are going to get generated from the resources that you create that you don't know up front, you can output those as outputs here. In this case, we're going to be creating an API gateway, which is going to be fronted with a domain, and we need to know what that domain is so we can actually make requests against that. So that's what that is doing here. We're just pulling out some of those values so they'll be available to us. So we have our actual SAM template. We have our Lambda function code. Now let's actually get that built and deployed. I'm going to get some credentials first. And the first thing I'm going to do is I'm going to run what's called the SAM build command. So this build is going to actually build my application, my function for me. If I had some dependencies in like a package.json or a Python requirements file, it would install those. It's going to get my zip files all ready to be uploaded to the cloud for this. And then once I do that, then I need to do sam deploy -- guided. The first time I run this, I need to do it with that guided flag. And that's just going to set up some configuration options for my application. I'm going to type in a stack name, which is Lambda DynamoDB Workshop, the region I want, a few other things here that we can pass through. All right, so now it's actually performing my deploy once I've gone through all that stuff. So it's submitting that CloudFormation template up to CloudFormation, and it's saying, hey, I actually want to create these resources, and now CloudFormation is doing that behind the scenes. This is going to take a few minutes, so while we're doing that, I want to look at a few other things. Number one, when I ran that SAM build command, what it did is it created this .aws-sam directory here, and it has this build directory in it, which has my function code and all that stuff. It would have my dependencies in it. If I need that, that's what's going to get turned into a zip file and uploaded up to the cloud to handle for my Lambda function. Additionally, when I did that sam deploy -- guided, I saved a configuration file, this samconfig.toml, that saves all the parameters I entered there. So the next time I do this, I don't have to do that -- guided. I can just say sam deploy. It's going to read the config from this file and use that to deploy, which can be good for CI/CD or different things like that. You can see down in the console here, it's actually creating these different things. Oh, perfect timing. Okay. So my deploy just finished. It says I successfully created, updated this stack. So what it's doing is I'm submitting that up and saying, hey, I want you to create this Lambda function. I want you to create this API gateway, all these different routes. Let me know when that's done. That is now done. We can see our outputs here. Outputs, remember we wanted to get our API gateway endpoint, and we have that available here. One thing I forgot to mention here, back in our Lambda function, in our body, we're just returning like a hello world message, but we're also going to be returning that event object that came in. And I'm just going to do that so we can inspect that event and give you a sense of what that looks like, how you can operate on that in your Lambda function. So let's go to Chrome here. I'm going to paste this in. So I just went to our route that we have. You're going to have a little different domain than I have, but something sort of like this. You can see I have this hello world message at the top of what we have. But we also have this big event object, right? And that's what was passed into our Lambda function based on our HTTP request that we can act on. So it has the resource and path that it was on. It has the HTTP method. It has all these different headers. If I want to, vary behavior based on headers, or maybe use that authorization header to do something with it. So it has that. It also has, if I put in a payload body, that would be available there. It has some other request contexts, things like that. Another thing I want to point out here is it has this query string parameters property. And right now it's null, but you might use query string parameters to set a count on some listed events, or maybe filter or something like that. So that's where you would access that. I'll just show what this looks like. If I go back to my address bar and maybe add a query string parameter, I'll do, name equals Alex and enter that in here. Close that out. Now I have this query string parameters is an object that has name in there as a key, and it has that Alex value. So, if I'm using query string parameters or requiring certain query string parameters, I can access it in my Lambda function with that, right? So you can see how that event is customized based on what's actually happening in that event that's getting written to you. I'm gonna do a quick look through the chat stuff. All right, looks like mostly Git clone issues, so hope we're doing well. Feel free to drop questions in here as you go, but otherwise I'm just gonna keep on rolling and doing stuff throughout. So let's go back to our application here. And I'm gonna check out the second branch. And so far we've created a serverless application. It has Lambda, it has API gateway, but we want even more than that, right? We want to use DynamoDB in our application. So let's add our DynamoDB table. And what we're going to do first, we're going to look at, we're just going to set up the infrastructure for our actual DynamoDB table. So DynamoDB table is infrastructure. It's another resource. Let's go to our SAM template to create that. So in our SAM template, again, we have that resources. We have that main function still. I'm just going to collapse that down so we don't need to see it anymore. But now I've added a new resource in here, and this is DynamoDB Table. It's of type AWS DynamoDB Table. So again, every resource you create in CloudFormation, you have to specify the type of the resource it's creating. So in this case, it's a table. And then I have to specify the different properties I want to configure my table with. So a few of these are around the primary key that Pete was mentioning earlier, that partition key in particular. I'm also showing how much provision throughput I have, so how much actual read and write capacity I want against my table. Again, if you're using that free account, you should be good there. This also fits within the free tier if you're not using that, so you should be hopefully good for this workshop demo. There are a bunch of other optional attributes on DynamoDB tables that I'm not specifying. This is sort of the bare minimum. One thing I would say is you can specify a table name if you want to, and when you're referring to your table in your application, you're going to use that table name to identify your table. But you don't have to specify it in CloudFormation. If you're using CloudFormation and you don't specify a table name, AWS is just going to create that table name for you and return it for you, and you can do that sort of more programmatically. So that's what I choose to do, but I'm still going to need to pass that to my application somehow. So just again, using outputs here, I'm showing how we can actually get the table name of our DynamoDB table using outputs, using CloudFormation there. So we'll do that. So yeah, we've got our table declared in our template, but now we need to run through that build and deploy process again. So I'll do that SAM build process again. It's going to prepare our Lambda function, going to prepare our SAM template, and then I can do SAM deploy. And just like we did, one thing to note here is I didn't have to do that -- guided because I have that SAM config.toml. So I just did SAM deploy. It's going to pick up all that configuration options and keep rolling there. Stop and take a drink while this is deploying. And one thing that's nice, I talk about CloudFormation as infrastructure as code, and it allows you to codify the resources you want, but also CloudFormation itself is like a stateful place for you, right? So if you submit up this CloudFormation template and you have, hey, you had previously created 5 of these resources in this template, but you have a new resource, it's not going to do anything with those other 5 resources. It's just going to let those go, but it's going to say, oh, you have a new resource here, or you've updated some resource. I need to make that change. So it's only going to do the new things it needs to do every time. It's not going to create that infrastructure from scratch. So it's going to be a lot quicker, things like that. So you can see I've successfully updated our stack here. If I look at my outputs now, I now have the name of my DynamoDB table, which is going to include the stack name of my CloudFormation template there. All right, so now we've actually created our DynamoDB table. I want to use it in our application a little bit. We're still not going to be reading and writing from our table. I just want to show some interaction mechanics of working with DynamoDB. So I'm going to check out the second branch. I'm going to do a build and deploy right now in the background, just so we're not waiting for a deploy later. But I want to walk through some of the code changes we're making here. So how do I actually use DynamoDB in my table? In my application. DynamoDB is an AWS service. You're probably going to be using the AWS SDK to interact with that. So one thing I like to have is in my source directory, I have this client.js file. This is just sort of a utility file that I have in my application that helps me with a few things. I'll walk through it here. You can see at the beginning, I'm importing the AWS SDK. So this is for JavaScript, pulling that in. But whether you're using Python, Java, C#, whatever, there's going to be an SDK for your language. You'll pull in that client. I'm setting this global client variable to null, and I'll talk a little bit more about that in a second. And then I'm creating this get client function. This function is doing 2 things. First of all, if you look at this, right away when I call this, I'm saying, hey, if that client variable is not null, let's return that right now. So right now, it's null. It's going to skip this, but we'll see that in a second. But then, if that client doesn't exist, I'm going to be creating this new DynamoDB client and assigning it to that client variable, and then I'll return that client back. So what this is doing is the first time we run through that function, that client doesn't exist. We'll have to initialize it and return it. But then in subsequent times, we've already set it out here, and we'll get that sort of reusable client there. Two reasons I'm doing that here in Lambda. Number one, I like to sort of centralize creation of my clients so I can handle things like configuration options, right? HTTP options, things like that. If I have 10 different Lambda functions, I don't want to create clients in each one of them with different configuration options. I want to set it in one place. So this is an easy way to do something like that. But the second reason I'm centralizing this client creation is I can reuse this client instance across multiple invocations of my Lambda function. So we won't get super deep into how Lambda functions work, but it's this sort of stateless compute model. They'll run these function instances on demand for you and create new ones or spin down old ones as you need to. But if you have a lot of requests in a row, you can reuse that function instance across multiple requests and reuse things like this DynamoDB client across multiple requests. And that's gonna cache that client for you. You won't have to do the TLS handshake every time. It's gonna make your response times a lot quicker if you cache this outside of that function. So more details in the PDF if you wanna look into some of the details on how that works there. So that's how we're getting that's how we're creating our client. Let's go back to our Lambda function and just see some small changes we made to make this work. Number one, we're importing that get client function from our other file because we want to use it. And the one thing I'd like to note here is like we call these Lambda functions, but don't think you have to upload don't think like a function in your programming language, like a little tiny bit of code, right? It's sort of larger than that. I like to think of Lambda functions more like handlers, right? You're handling a particular use case. You're handling an HTTP request. You're handling a batch of records from SQS or something like that. So within your Lambda function handler, you might call out to other functions. You'll call other methods. You'll do things like that, like you would in your programming language. It's not sort of as small as a single function in your programming language. So we've got that here within our handler now. What we're going to do is we're going to retrieve that DynamoDB client, and then we're going to call the describe table operation against the DynamoDB service. And that's just going to tell us details about a particular table. You can see here we need to pass in a table name. And to do that, we're going to reach into our environment variables to fetch the table name. So I'll show us in just a second how we inject that table name into our environment, into our Lambda environment using CloudFormation. Finally, once we get that response back, we'll just return it in our payload body. So in a second, when we go visit this code, we'll see that updated information in our response. All right. So now we've done that, let's go hop over to our SAM template, our CloudFormation template, and just look at a few updates we have here. A couple updates I want to call out. Number one, within our Lambda function, we've added this environment property with some variables in it. So if we want to inject environment variables into our into our Lambda function, we can. One thing we want to add in there is our table name because we're getting that generated dynamically by the CloudFormation service. So we want to make sure our function has access to that. So we'll just pass that in. We also have another environment variable that's related to that connection reuse that we were talking about earlier. Last thing I want to say is we have this policies section. So whenever you're using a service in AWS, you need to make sure that you have permission to use that service, and you need to authenticate who you are, but also have authorization to use that service. The framework that AWS uses for this authorization and authentication is AWS IAM, and that's what we're going to be using here. So your Lambda function will be associated with an IAM role. And when your Lambda function is created, they're going to inject temporary credentials into it that can authenticate as that IAM role. You need to make sure you're authorizing that IAM role to perform certain actions in your application, including describing your table or reading or writing from your Dynamo table or things like that. So what we're doing here in this policies section is we're adding this statement, this IAM statement, that's allowing you to do the operation you did. So three elements of every IAM statement. The effect, you want to allow this particular operation that we're describing. What action do you want to allow here? And we're doing DynamoDB describe table. So the format is always going to be what service are you working on, and then what API operation within that service. So we call it the describe table operation. That's what we want to be calling here. And then finally, you need to specify to which resource it applies here. And we're specifying the specific DynamoDB table that we created here using the ARN. All right, cool. So now that we have that, let's go back to our application. I'm just going to refresh this to show how it changed, right? Now we're not returning the event back, right? We're returning that table response back that we got. You can see our hello world message still, but you can also see this table response. This is just what came back from the DynamoDB service when we call describe table. You can see it has our table name, some other attributes, table status, things like that, item count, all that stuff. And all we're sort of verifying here is, hey, within our Lambda function, we were able to call out to the DynamoDB service. We authenticated ourselves. We had authorization to do that, and we sent that back to us, right? So we've configured our table well. We've configured our permissions well. We can do that stuff. But that's not actually what we're trying to do in our application, right? We actually want to read and write data to and from our DynamoDB table. So let's move on to that step next. We just had one question there. Can we use parameter store? You can use parameter store to store keys and values with your Lambda function. Absolutely. So, in this case, we're passing in environment variables like the DynamoDB table name, and that's something that's fine with environment variables. But you might have like secret data or something like that that you wouldn't want to put in environment variables because it'll be in CloudFormation, and it'll also be available to libraries within your function environment. So in that case, you can use something like parameter store, which is just like a key value store for little secrets and things like that. You can read those dynamically at runtime for something like that. And Pete also made a mention of reusing that connection within DynamoDB. All right, so moving on to step 3 and get that deploy going. But so now in step 3, I want to show how we're actually using DynamoDB for data operations within our Lambda function, right? We want to write to our DynamoDB table. We want to read from our DynamoDB table. What does that look like in a serverless application? How do we set some of that stuff up? So the example we're going to have here is basically just like a counter type site, right? We'll have a web page you can go to, and the URL route will be /tag/ and then there's the name of a tag. So something interesting, sports, AWS, technology, something like that. Every time someone goes to that particular path, we'll look at whatever that interest is, that tag is, and we'll just increment a counter so that people can see, how many people have visited this particular site, right? So that's what we want to do here. I want to walk through a couple things. So we'll make a new Lambda function that we're going to have here. This one's called record visit, right? So recording someone's visit to a particular web page. It's going to be similar in a lot of ways to what we've already done, right? So we have our handler function that has that same event context function signature there. A couple things to call out. When someone makes an HTTP request to a particular tag, we need to know what tag it is, and what we're doing is extracting it from the path parameters object on the event. I'll show you how you set up path parameters, right? I showed you query string parameters and how you can get that. But now if you're talking about your HTTP path, /tag/ and then a tag name, how do you configure that? We'll look at that in just a second. Once we have that actual tag value extracted, then we'll go do an update item operation to our DynamoDB table and just increment the counter for that tag. That's what's going on in all that SDK code. And finally, we'll return an HTTP response just like we were doing before. Again, status code of 200, but this time we're actually going to return some HTML, right? We're not going to return JSON. Maybe we actually want to display some HTML. So you can do that if you want to. The one thing I want to call out here is if you're doing that, you need to include headers like content type of text HTML. It's going to assume JSON naturally, so you want to make sure and pass something out like this if that's what you're doing. But you can include all kinds of headers back in your response, just like you're making HTTP responses in something else. Okay, so that is Now we've written our new Lambda function to actually help record this particular visit. Let's configure that also in our SAM template using infrastructure as code. So I'm going to go back to our template.yaml. In our resources, I'm going to collapse that main function. We still have that original function, but now we want to add a second function, right? This record visit function that's going to record a visit to a particular tag page. So we have that here, this record visit function. Again, this is type of AWS serverless function. You can see the properties we're indicating where that code is. Notice that it's a different handler file this time, right? It's that source/record visit file. It's not the main file. It's a different function or a different file for a different function there. We have our runtime there again. Events are going to be similar again. We're hooking up an API type event. But if you look at the properties, look at this path that we have here, right? We have /tag/ and then in curly brackets, we have tag. And that's how we set up those path parameters that I was talking about within our Lambda function. What we're doing, this is like a splat or some sort of regex to pull out an element of a path that you might have within routing in your application. It's saying, hey, match this general thing, and then extract that tag value and give it to me in my event as that path parameter. So you can use those curly brackets in your path to do that with API Gateway. Also having our environment variables there, and then our policy statement to allow that update item operation. So we've done that. We've set up and deployed this record visit function. Let's go actually try and visit our site here. So I'm back here, tag, and I'll go to tag AWS, right? See if it works. There we go. Your visit counts. So we went to this website. When we got this request, we extracted that AWS tag, we incremented the counter in DynamoDB, and then we said that visit counts, and then we've got this link for, hey, if you want to go check the count of that tag, you can go here. But we haven't actually implemented that yet, right? So I'm just going to record a few of these. Maybe I record another one, technology. Maybe I like technology generally, right? So we record a few visits there as well. So we're just hitting our Lambda function a few different times. But now we want to actually implement the count, right? We're storing all this data in Dynamo. How do I read it back out as well? So let's add a new Lambda function here. Do a SAM build and deploy as well. Again, I'm just doing the build and deploy to keep us moving, so we're not watching the deploy. But if you want to go back through this PDF, I think it'll be a little slower. You can do it at your own pace and actually work out the code as you want to. So let's look at this other Lambda function we have in this view counts file. What this one is going to do, someone's going to go to /counts/ and then a tag name, and it's going to display the number of visits for that particular tag name, right? So if I go to /counts/AWS, how many people have visited that particular page? So here's our Lambda function. Again, has that same function signature that we had before. Again, we're extracting that tag value from the path parameter because we need to know which tag we're looking up to find the counter for. So on our event object, we have that path parameters object, and I'm looking up the tag key to get that tag. Then I'm going to go to Dynamo and do a get item operation to read that tag out. And then again, I'm just returning HTML that's indicating, hey, how many total visits do we have for this tag? That's view counts. Let's go look at our template, right? Because we've written our function code, but we also need to make sure we provision the infrastructure using that infrastructure as code for our new function. So I'll close that record visit function. Now we have this new view counts function, right? So this is a new function that's allowing us to view the counts by hitting an endpoint. Same sort of properties we've had before with code URI, handler, runtime, things like that. The HTTP event should be pretty similar as well. Again, we're using that curly bracket syntax in our path to help extract that path parameter. So our route will be /counts/ and then the tag name there. We have environment variables again. The only thing that's a little bit different that I want to call out here is in this policies section. Remember before that when in this policies section, we were listing out these IAM statements that had the effect, that had the particular actions we wanted to allow, that had the resources that wanted to apply to, all that stuff. It can be a lot of information. if you AWS SAM has something called SAM policy templates, which are sort of like pre-built templates that configure all this stuff for you, and all you need to do is pass in, a table name or something like that. So in this case, they have this DynamoDB read policy. It's going to give you all the read permissions that you need on your table, and you just need to pass in a table name. So that can be a little bit easier for you if you want to look at something like that for these IAM permissions. All right, so now that we've implemented that, let's go back to our thing here. Let's click and check the count and see if this actually works now, hopefully. There we go. So now it changed to our counts/technology route up here. And you can see we have 9 total visits, right? So I went to that technology page 9 different times, refreshed it each time, and it just kept racking up the counts there. So we have 9 different people that have visited our site, or me visiting 9 times. So what we've learned so far in this third module, right, was how do we use Dynamo for these data operations in our Lambda function, right? And we saw how to extract information from that HTTP event, like the tag path parameter, and use that to run an update operation, to figure out the right item to read, how to do all that stuff. And not only that stuff, but how to configure like the IAM permissions and the environment variables to make sure you're working with your DynamoDB table. So that's the first way you want to work with Dynamo in your serverless application. You're doing those actual data operations. Now let's go and look at the second way, which is that asynchronous way, doing change data capture with DynamoDB streams. So what I'm going to do first here is check out. So Pete, as Pete mentioned in his talk, right, you can set up what are called DynamoDB streams on your table. And what this does is it just gives you that change data capture. Every time there's a write operation on an item in your table, whether you're inserting an item, whether you're updating an item, whether you're deleting an item, it's just going to drop a record of that write operation into your DynamoDB streams. And then you can process that like you process other streams, Kafka streams, Kinesis streams, things like that. And you can write it back into your DynamoDB table for aggregation purposes, as Pete mentioned. You can batch it into Firehose, into Athena, things like that, or you can send it out to other services or those things. What we're going to do here is we're going to write it back into our DynamoDB table. So imagine we're keeping track of total views across all these different pages, but we also want to maintain an overall view for the total number of visits to our site, and just get a sense of, hey, across all these different tags, how many total visits do we have? So what we're going to do is every time someone writes a record to Dynamo to increment a counter, we're going to go back and write to our table to increment like an overall counter for our table. So the first thing we need to do is enable DynamoDB streams on our table, and we do that in CloudFormation. So let's go back to our SAM template here. It's going to collapse all our different functions that we have here. And go back to our DynamoDB table, and if you scroll to the bottom, there's this stream specification property. So stream specification, you're saying, hey, I want to enable DynamoDB streams on my table. It's not, streams aren't available or enabled by default. You have to sort of specify them. So that's what we're doing here. You have to specify the stream view type, which is just saying, hey, when that write operation happens, what information do you want on that record in your DynamoDB streams? So in this case, we're saying new and old image, which means it's going to give us how the item looked before the operation and how the item looks after the operation. So you have everything you need to know sort of what changed and maybe broadcast that somewhere. Whereas you can also do old images only, new images only, keys only, things like that. So we'll just enable this here. Now that we've enabled this, we'll do a SAM build and deploy. I should have done that before. One thing I want to mention here is this is an sort of an in-place operation on your DynamoDB table. So it's not going to tear down your DynamoDB table and create a new table that has the stream enabled, right? It's just going to say, okay, we need to actually enable this operation on your DynamoDB table. You do need to be a little careful when you're working with CloudFormation. I'm going to look up that DynamoDB table resource and show what this looks like. So if I go to this DynamoDB table, this is like the reference documentation for CloudFormation. You can look at this stream specification property that we just set, and it says, hey, update requires no interruption. So that means if you update this particular property in your CloudFormation about a DynamoDB table, it's not going to interrupt operation of your table. It's going to work fine and keep all your data in there and all that stuff. But sometimes there's certain properties that if you change them, it might need to create an entire new resource because you've changed something essential about that particular resource. So if we look at like this table name property, right? The table name is how you identify a DynamoDB table. So if you change it, it's a totally different table. So you can see here that update requires replacement, which means it's going to delete your old table and create a new table in its place. So CloudFormation is really
Alex,
great for. Yeah, sorry.
I think maybe one other example is maybe changing the primary key, right? Because that's not
Yep.
something you just change on the fly.
Yep. Yeah, exactly. Exactly. That's a great point. So if we look, let's see, key schema. So, Pete was talking earlier about how you specify that primary key on your table. Got to have that partition key, maybe have a sort key in there as well. But you have to specify that when you create your table, and it's so essential to your table that if you want to change that later on, it's going to create a new table for you. Drop all your old items and create a new table. So you can see here in the key schema, which has that primary key, that update is going to require replacement, which means it's going to replace your old table. All right, so we've got our stream has deployed here. So we didn't make any code changes or anything like that. All we did is just sort of enable our new DynamoDB stream. Let's actually start processing that stream, right? What we want to do is create a Lambda function that's going to process that stream. It makes with Lambda, it's super easy to do stream processing, whether you're using Kinesis or DynamoDB. It's basically just going to invoke that Lambda function in response to a batch of events, and you don't have to worry about sort of where you are in the stream or any of that state management, which is really nice. So we'll set this up here. We'll look at the stream processor function that's going to process. Actually, before we do that, I want to look at this event.json. I just have a file. Sometimes I have files that show me what the shapes are of the events I'm going to have, whether that's an API gateway event or in this case, some DynamoDB stream records events, right? What am I going to get? What is my Lambda function going to be invoked with? You can see it here. It's going to be an object that has this records key and has an array of records. So it could be multiple records that I'm getting from my DynamoDB stream. Here's one of the records here that has a DynamoDB property, and it shows this new image. So this shows what that image looks like after this write operation that just happened, right? You can also see down here, it has an event name of insert. So you can see, that this was a new item that was inserted into our table. It didn't exist before, and it's just being inserted into our table. I scroll down, and it has another example of an event here that has both an old image and a new image property because this was a modify operation, right? So we are modifying an existing item. So it showed us both how it looked before the update happened and how it looked after the update happened. So this is what we're going to get put into our table, into our event, our Lambda function, sorry. Starting to lose it here late at night. So here's our stream processor function. And what we want to do is, again, we want to take all these different counter operations that are happening across all these different tags and basically sum them up and increment a global counter for our table. So what we're doing here, first of all, we need to make sure we're filtering out records that aren't, or that are like deletes or something, right? If someone deletes a record from our table, that's not what we're interested in. We're only interested in these increments. So we want to make sure that the event type is either insert or modify. Another thing is we want to filter out records that are using our global counter key, right? Because we don't want to sort of infinitely loop ourselves where imagine someone visits a particular tag, we process that record and say, okay, we need to increment our counter. Well, when we increment our counter, it's going to drop a record into our stream that we're going to get processed again. So we want to make sure we're filtering out those records so we don't just sort of keep counting upgrades to the global counter as ones that need to, again, upgrade the global counter. So we'll do some initial filtering on our stream records, and then we'll just do an update item operation like we were doing before to increment that counter and return it back. One thing to note here is the way the stream processor works, we don't need to actually return anything to the stream processor because it's not like an HTTP API gateway where we need a response to that, right? As long as we sort of finish this call successfully, it says, okay, I just need to go to the next batch of records in my stream processor. Last thing, or another thing I want to show is in our view counts, on our, if someone's viewing counts for a particular tab, we want to show the overall view now too. So I just updated some code there to pull that overall code. Sorry, I'm kind of speeding through because we're getting short on time, I know. So I'll pull that total key as well, just so I can show the total number of views there and return that there. Do a build and deploy because I can't remember if I did, but all right, last thing I want to show is in our CloudFormation template, we need to set up our stream processor function just like we've done before. So we have, again, another Lambda function. This is our fourth Lambda function that we're setting up. These are all independent of each other. A lot of these properties look the same, right? We need to say where that handler is. We need to say what the runtime is. The one thing that's different here is we have a different type of event configured on this one, right? In our previous ones, we had API gateway events. They were handling HTTP requests. But in this one, we want to be processing our DynamoDB stream. That's a different type of source. So here, the event type is of type DynamoDB. It's not of API like we had before. You'll also notice that it has different properties here, right? So we're passing in the stream ARN that we're processing. We're passing our starting position in that stream and then the batch size. How big of options do we want? So these are things that are specific to processing a DynamoDB stream as opposed to the method and the path for when we had API gateway there. We have environment variables and policies and things like that as well. And you can see our stack was created and updated here. So let's go back to this and let's go to a new one. Let's just go to tag sports here. All right, so my visit counts, right, for tag sports. I'll maybe do it 3 times here. And now let's go check the count for tag sports. Oh no, my stream processor didn't happen fast enough. Sometimes it takes a little time for it to start happening. I should deploy it sooner. The demo gods. All right, go back to this tag sports a little bit. Okay, here we go on our counter. So now the tag sports has 5 total visits. It also says, hey, you have 5 visits across all your pages, right? Because we've done that. So now we've got this asynchronous processing where we're taking those changes in our DynamoDB table, we're feeding them back into that table to handle aggregations and things like that. Last point I want to point out here is you may recall, hey, we visited other pages already, right? We already visited the technology page. Like, how does this work, right? Because we had already visited the technology page 9 times, but we only have 5 visits across all these pages. Like, what's going on here? Where's the fluke there? With DynamoDB streams, you're only going to get the right operations that happen once you enable that stream. So if you already have data in your table and now you enable that DynamoDB stream, it's only going to have operations going forward. It's not going to have anything that happened before you enable that stream. So if you need to sort of backfill some data and get this total counter to account for previous operations that happened, you'll need to do that yourself. It doesn't have all the right operations that happened from the beginning of time. Yeah, so that is that. I think those were all the points, and I know that was fast and there's a lot going on there. So the big things I would say is I hope this gave you an introduction to it and you're able to follow along a little bit and understand those points. Take some time to go back and either watch the recording or go through the PDF and work through it yourself. 2, again, main takeaways I want you to have from this is what are the ways we can use DynamoDB in our serverless applications? We can use it for our actual data operations to store that stuff. We can also use serverless applications to process those DynamoDB streams and react to the things that are coming out of our DynamoDB table. So that's the DynamoDB specific stuff. I hope you also learned a little bit about what is Lambda? How does that Lambda function work? How does that event-driven compute work where I hook it up to those events? And how do I use infrastructure as code like AWS SAM to manage all my application where I'm provisioning Lambda functions, I'm provisioning API gateway, I'm provisioning DynamoDB. You need to manage that with something, and AWS SAM is a good choice for that. So again, I know that was a whirlwind. Any questions we can answer? We've got some time to answer questions and handle any of that stuff.
Alex, I think there was a question from Sri asking whether it would be possible to send an email via Lambda by using values that are stored on DynamoDB, like to check thresholds and then send an email.
Yeah. So we have a threshold value in Dynamo. Yeah. So the big part there is might need a little bit more about your use case. Like, do you want to be checking that sort of downstream from DynamoDB streams and be looking at all those and see if a value ever increases beyond something? Or is it like more like a cron job type thing where you say, hey, every hour, I want you to run a query. I want you to go hit your DynamoDB table, find that threshold, and let you know if it's exceeded that. But whatever way it is, you can absolutely do. Okay, so Sri said, let's say a stock price goes above a certain value. Again, is that triggered by a cron job? Like, are you checking at a particular time, or are you like feeding a bunch of data into your table and you want to know if like one of those operations passed a threshold? Let you answer that. But the answer is yeah, you can absolutely do this. The AWS has like mail services, so there's simple email service. Okay, so existing values, run a Lambda using cron. So yeah, absolutely, this is a great one for Lambda. Lambda has cron-like functionality. So we talked about different event sources for Lambda. It can be API gateway, it can be SQS, it can be DynamoDB streams, but you can also have a scheduled event where you just say every hour, every 5 minutes, every day, wake up and perform this operation, and then you can act on it as you want. And Lambda is just code, so you're flexible. You can do whatever you want within that Lambda function, within limits. So you could query that DynamoDB table and then, have your logic to say if it exceeds this, go send this email or something like that. So two things I would check out there would be scheduled events for AWS Lambda, and then Amazon SES, which is the email service to send that email. Yeah, great question. And just to riff on that just a little bit more, like there are certain things that Lambda just makes maintenance of a lot easier. Like I always had a cron box, right? We had a box that like ran a bunch of different cron jobs, and like they're failing sometimes, you didn't know about it, or something happened with the instance, and now like no one knows what's on this like junky cron box. But now with Lambda, right, you can have that in a more visible place. You have logs, you have alerting on it. It's a lot easier to set that up. Same thing with like stream processing, right? I talked about that a little bit earlier, but if you have these streams, DynamoDB streams, they might have lots of different shards in that stream, and processing that, there's some tooling around it, but it can be hard to like maintain all the different instances to actually process that. But with Lambda, it really is just dead simple. You're just like, I'm operating on batches of records and doing what I want. And as long as my Lambda completes successfully, it's going to get the next batch of records and create processing, and it really works really nicely. Same thing with queue workers and queue messages as well. Stop sharing my screen. Any other questions? Cool. You're none. I mean, thanks everyone for showing up and taking time out of your Saturday. Pete and I and Neely and Raina and I and Amit we appreciate it for sure. And thanks for doing that. Feel free to reach out with any questions on some of this stuff. I think we'll probably get the video to you in some way. And again, use that PDF and walk through it as well, supplement in those different ways. But yeah, thanks everyone for coming.
Thank you,
Pete and
Alex.
Alex,
Thanks for
before I
staying up so late.
Yeah. Yeah.
Hey, Pete and Alex, before I let you guys go, just a quick question. What's coming for DynamoDB in 2022?
That's a great one for Pete right there. There we go.
More
More.
features. Yeah, we're working hard on a number of different areas. I would say, having been around DynamoDB for some years, about 5.5 years now, we did. I would say the first few years I was involved, we did a lot of work on making things scale a lot better and a lot more forgiving around hotkey situations and those kinds of things. The last year or two and going forward, we're spending a lot more time on things like making backup and restore really, really simple, integrating with other parts of the AWS ecosystem. One of the most exciting things for me, I would say, recently is the export to S3 feature, because I know over the years there were many customers who were doing scans and trying to periodically take their entire DynamoDB table and dump it out to S3 objects, and now it's literally a click in the console or a simple API call. So DynamoDB is an incredibly powerful service, I think, and a lot of what you'll see us working on in the next year or two will be making it even easier to use, right, and easier to integrate with other parts of the service. Very often for complex applications, you'll see DynamoDB combined with some other databases. Sometimes you want to be able to do graph, right? You want to have Neptune, and you want to have QLDB and various other features or other AWS databases. So things like glue elastic views, which is something that the team is working on at the moment, will make it so much easier to be able to move data around and shift and move and match different access patterns between different database services. So that's my prediction, and I'm part of the product team, so I might have a little bit of inside information on that. We want to make it even easier and nicer for customers. It's really important.
Yeah, and I would just, I can't speak to some of the forward-speaking stuff as much as Pete can, but some of the stuff that's come out in the last couple of years, adaptive capacity was just such an amazing game changer around, how they're helping you make the most of your capacity on demand billing mode, where you're doing pay-per-use billing, just like Lambda and API Gateway. That's amazing. DynamoDB transactions, export to S3, like a lot of pretty cool stuff that's come out that's really sanded off some of the hard edges with Dynamo.
I'm going to put you on the spot here, Alex. What's the one big feature ask that you have? I know we talked a little bit earlier, maybe before the session, about your wish list for DynamoDB.
Mm-hmm.
If you had to pick one, what's the number one ask that you would like to have?
That's a tricky one, because it depends on what we're talking about. I think if I was really asking for the world, it would just be like easier integration with other data sources or things like that, where Dynamo is awesome at these OLTP use cases. It's great at getting individual items or getting a range of records. But if I have aggregations or if I have complex filtering, it's not as easy, and now I have to pull in Elasticsearch and sort of do my own type stuff there. So whether that's a sort of side supplement to Dynamo or whether it is just an easier route to getting something in, I think that's the place where that would save a lot of headache for me the most. I would love to see it just like sort of integrated with, not with Dynamo specifically, but just like little add-on type thing in somehow, because it's going to have different scaling properties and performance properties than the rest of Dynamo. But I think that'd be pretty interesting.
Awesome.
Yeah,
I agree. That would be cool. Does anybody else have any other questions? I saw Amit posted some links in there for feedback. We'd love to understand, if there's anything we could do better in future sessions, things that you'd love for us to, maybe have other sessions about and dig into.
Yeah, definitely. And truly don't hesitate to reach out if you have any questions, in the future. I think Pete and I and members of the Dynamo team are available. So email, Twitter, whatever it is, we'll just be in touch.
Great. Alex, you
Thank
did
you,
a
Alex,
fine job
and
tonight. There are almost no questions. This is great.
Yeah, I don't know. That was because I was rambling in my half awake state. But yeah, I hope so. And thanks for doing the presentation, Pete. You did a great job as always.
Thank you.
Alex and Pete, Faisal here from the Hyderabad user group. Once again, I just want to thank you both for, doing this session. I know it's pretty late out there. So, thank you for sticking through this and giving us an awesome session. I mean, we have so many other questions around, things like IoT data integration with DynamoDB and all of that, but probably we'll leave that for another day. I just want to thank you from our side.
Sounds
Thanks for
great.
setting this up. It was fun.
Yeah, thank
Any
you.
chance I get to hang out with Alex, I'm there.
Let's do it.
All right.
Rafting in Oregon though. So
Okay. Bye, everybody. Have a great
See
weekend.
y'all.
See you
Bye.
later. Bye.